And here we are at the third dialogue series, the Geo Data Sharing and Data Management Principles dialogue series, organized by the Geo Data Working Group. My name is Bente Liljaby. I'm going to be the moderator at this dialogue. And with me, of course, is Marie-Françoise Vadreau, and I will introduce her also in my first introduction to the concept of the dialogue series before we start on today's topic, that is data management principles number 1, the discoverability. But first, I will share my screen. So what is the Geo Dialogue series? Well, first of all, we wanted to advocate these wonderful data sharing and data management principles that we have developed in Geo. Not everybody are fully aware of what exactly they are and definitely not able to use them. So therefore, this dialogue series was created to create awareness around it. And we want it to be a dialogue with the Geo community. There are so many activities in the Geo work program, in the different working groups, etc. So we wanted to create awareness in this community. And doing so, we also wanted to create some capacity development resources, sustainable resources. So all of these dialogues are being recorded and published on the Geo website, on the Geo Knowledge Hub, and it will be material that we can use, all of us in this community. And why particularly now? Well, we want to engage particularly now because we have become even more conscious about the necessity and value of in situ data and the complexity that they meet, for instance, with respect to the space based data providers that have been more coordinated for some time. We also wanted to see more on the law and policy dimension of data sharing and data management principles. So that's the background for the dialogue series. And as I said, we want to incorporate the in situ perspective, the law and policy, such as licensing and ownership, you know, different perspectives on the data that needs to be sorted out to be able to share it and make use of it. And we looked to the Geo work program for examples, and all of that we try to put into this dialogue series. Each dialogue will thus consist of a theoretical part where we introduce the principles. We show an example or two, and we also try to relate the Geo data management principles to the fair, care, and trust in their complementarity on comparison, etc. So that's the structure of the dialogue series. We have 8 or perhaps even 9 planned now. And you see the arrow here is how far we have come. The 19th of September, we have discoverability. This is the topic today. Every Monday from 4 to 5:30 Central European time. So the data sharing principles has already been discussed last week, where we went through in more depth on the individual perspective or the data sharing principles. And here you see the 3 of them. I don't want to spend time on presenting them here now because we learned from experience that we need the time to discuss. We want to have a dialogue, so we go straight to the discoverability. That's the first principle we now will address. And the short version is data and all associated metadata will be discoverable through catalogs and search engines, and data access and user conditions, including licenses, will be clearly indicated. So what does this mean in practice? And the theory, more depth in the theory behind it, what it means in praxis, and how does it relate to other principles that we know of. So I promised to introduce Marie-Françoise. Many of you already know her, but all the same, she is the director of the ODC Innovation Program. She's been deeply involved in all things data management, data principles. Currently, she's working very much on eShape, a major contribution from Europe to GEO. She's been on the GEO Expert Advisory Group. She's in the program board of GEO, and generally a strong resource for the GEO community. And here I am. For those of you who don't know me, I run a small research and consultancy company. I have been involved and engaged and super excited about making data interoperable and useful through the entire value chain. And I have been in the GEO community since 2004 and have had so many different roles. I'm in the GEO data working group now. And I have also been engaged in the subgroup GEO Gender on Equality and Inclusion. And this is what we try to do here in the dialogue series. By the way, we try to find people that we know they're experts, that we also acknowledge that they come from many different regions, countries, and ages also. So if you have tips for us on individuals that you think will be a valuable source for us, please send us a hint, and we will be looking into that and see if we can fit that into the program. Now, we want you to be engaged, so please use the chat, raise your hand if you want to speak, and we have, as usual, a poll. So very simple questions that will bring us together. And today we are dividing you into data providers and data users. Some of you are both, some of you are neither, but that's the perspective we have today. And you will get questions about that, and we will discuss after the poll has been, after we show the results of the poll. So be patient. We hope that this will help you also, that trigger some questions for you that we can then discuss orally in between the presentations. Now, discoverability. I think we are ready to learn about the first speaker. Well, first here is the program. So now we've done with the introduction to the dialogue series. The first thing we will learn about now is Chris Schubert will introduce us to discoverability principle. Then we will learn about the GEO Discovery and Access Broker, and Paola Massetti will do that. Next, GEO's Data Hub, a federated data catalog, will be presented by João Andrade from Demos in Portugal. Better discovery through better standards for describing data context will point us more to the future, and that will be Robert Atkinson from ODC. Then we will see a success story from one of the flagships, Data and Metadata Discoverability in the Global Observing System for Mercury by Sergio Cinerella, so from CNR Italy. And Paolo Massetti is also from CNR Italy. Okay, so Chris Schubert is one of the co-chairs of the subgroup of the data working group for data management, data sharing and data management. He is working at the University of Technology in Vienna, a library. Coming from geology and computer science, it looks like he was inspired to do ontology-driven web services, land cover analytics, very involved in EU Inspire. We know that that's super important for interoperability, and also supporting climate research. He has also knowledge not only about the GEO data sharing and data management principles, but also the FAIR principles. So, Chris, I give the floor to you, and we will see what and learn about the first principle. Stop sharing, and I hope you can share now, Chris.
Yeah, thank you. Yeah, thanks a lot, and Bente, and also for organizing this task here, where we step in, describing one of the first principles here on discovery, and especially also on metadata. What we did also as review process in the last month together within the data working group, or geodata working group. So on the one hand, to present or to talk about metadata seems a little bit boring, or can be a little bit boring, and we have also to find what's the burden working with metadata itself. And in the end, probably people are happy to get data and doesn't care about this context description anyhow. So it's yeah, this describing or working with metadata is always a kind of last mile in the process on data creation. So digital processes and the availability of tools and data services and cloud computing requires a much higher interoperability and sustainable and reliable concept, also semantic concept, reference types, and so on. We need for all these data-driven processes for observation and experiments, data ensembles, and so on. And it's not only about being findable and searching through catalogs as a human action. So it's also about human machine interaction and machine-to-machine interfaces here. The question, of course, is, or I do not really create a new picture on the importance on metadata and so on. We will have it, hopefully also have it in the for the other presentations and also in the discussion. So in the end, this point on metadata for discovery, it covers all the following aspects for the next weeks and a month, where we want to describe in detail the data management principles in particular here. So yeah, here we have we got also this text from Bente. So that the short version here is that data and our associated metadata will be discoverable through catalogs, standardized catalogs, and search engines. So yeah, moreover, data access, use of conditional licenses, and so on, has to be clearly indicated, or will be clearly indicated. This data management principle number 1 is also running with, if you look on the document, on a 3-page examples and more detailed information, and information how you can reach this. And here I did some just some I would say topics here to describe it a little bit more in detail. Yeah, the first thing is, of course, discoverability is designed to make data and metadata findable by users. So and discoverability in the end, it's a demand or user-centric demand. So the user want to have some information about data. And the question is, can we reuse data in a sustainable workflow for cloud-based data-driven processes or data cubes and so on, what is increasing as collaborated method in the last years. So we need, of course, information about licenses, a kind of agreement, also to have or to be ready for machine-to-machine actions in a federated system. So we need also an understanding if the items or if the data is it really exact is what we are looking for. So we need information about data quality, about this common understanding, such as used or with controlled vocabulary here. As well, it's also important to describe within metadata, so the credits of the data creator, data provider, so from individuals to institutions, and also get a persistent access via data citation on single data fragments and artifacts you using for or you reuse for your data or for the data process you have in mind. And we have to be, of course, create and all these metadata schemes and so on need a compliancy to existing standards. Here are just some examples, but I think we will hear a lot of more for the next presentation. And what we did also, and Carl Benedict showed in one of on the first meeting or dialogue series, also this crosswalk, which is quite important to have it here regarding the FAIR principle, regarding trust principles and so on. And this is just an exercise here where we work on it. Being in time, so I will stop here and thank you, and will hand over to Bente again. Yeah.
Thank you very much, Chris. I see that there were some analog data there on your last picture.
Yeah. Yes. Yeah.
Not so machine readable.
No, but the importance is also really to work on collection things, and this is a picture I made here for the Natural History Museum, and
Right.
yeah.
So we have all sorts of data, so it's not so straightforward to make this discoverable. We had a question to your presentation, Chris, so thank you very much. By the way, it was, maybe you can take the floor. I think it was Brian something, let me see. Yes, Brian.
Hello, good afternoon. This is Brian O'Connor here at the UNCCD Secretariat. My question to Chris was if licenses can be made machine readable, because often they contain complex legalese or clauses that can't necessarily, that needs a human really to interpret them, or is it kind of some licenses can be machine readable and some can't? So that's my question to Chris. Thank you.
Yeah, probably we get. I'm not an expert in within these licenses task. Probably we can also have get answers from more experience working or a project which are working on. But in the end, it's quite important really to find an approach where you can merge different licenses and find to get really an extract out of that for reliable reuse without any risk.
Yes, and I think Kate Weber, who was here in the first from Google, she was addressing this particular issue, as far as I remember. And so they are working on it in Google. And maybe maybe Rob Atkinson from ODC might also highlight or come partly into this in his talk later today.
Okay, so, interesting. Thank you very much.
Yeah. Okay. I think I will share now with you the poll before we start with the broker. Share results. You see the results? And not surprisingly, many of you are actually both a data provider and a data user. You see then but there are more clean data users than data providers here today. And we have also some that are neither of them. But I think the main point here is just to, at least for me, is that very often we are both data providers and data users. I think this is a natural thing when you are setting up applications and services and modeling, etc. Okay, now, Paolo. I will go back to my presentation. Paolo Mazzetti, he is a senior researcher at the National Research Council of Italy, CNR, the division in Florence, and he has been into electronic engineering and also philosophy. And we all know you, Paolo, being deeply involved in the development of GEOS and the DAB for many years. But here we see that you are also involved in many other projects. The coordinator of a LIFE project, so a new LIFE for drylands, application of remote sensing to land degradation, monitoring and assessment. And you have been in GEO since 2010 and participated and contributed to many boards and working groups. And you are on the program board and co-chair of the GEOS platform operation team. I think you can explain then what you do in the GEOS DAB and the GEO DAB now. So the floor is yours. Paolo?
Yep. Thank you, Bente, and thank you to all the organizers for this opportunity to give this presentation. I try to share my screen. You should see the screen and the presentation, correct?
Yep.
Okay, so yes, I'm going to give you some information about the Geo Discovery and Access Broker. And I would like actually to start with the reason behind the Geo Discovery and Access Broker. Basically, it tries to solve a communication problem. So for example, when you have people speaking different languages, you have a couple of potential solutions. The first one is to find an agreement. For example, let's speak English as we, for example, as we do in the science and technology community. And of course, this is an effort for those who are not natural speakers of English. A second solution is actually to have an interpreter acting as a mediator. And of course, here the complexity is all on the burden of the mediator. So why we actually choose to adopt the mediation pattern in GEO? Basically, because GEO has an heterogeneity challenge, actually more than one. One is related to the present. If we look at the engagement priorities in GEO, we see that most of them are multidisciplinary in natures. So requiring, for example, to discover and use different data sources coming from different communities. And different disciplines require different metadata models and related discovery services. For example, the biodiversity may require to accommodate taxonomies, climate simulation may require to accommodate multiple temporal axes, and so on. There is also a challenge related to the future, which means to keep the system viable, that is effective and efficient. And we know that technology advancement actually pose new requirements, suggesting new metadata models, new discovery services. All of us probably remember when, with the rise of linked data topic, with the rise of the CCAN, now with the cloud we have Stack, and probably we will have other in the future. And also there is a challenge related to the past, which is related to legacy systems, because some catalogs are part of existing systems with their own mandate and governance that cannot be changed for legal, financial, and technical issues. So it's expected that we have a residual and possibly a reducible heterogeneity. And this is the reason why we resorted to mediation. Of course, mediation may have benefits, but have also some concerns. Just to mention some, it introduces a single logical or virtual point of failure. It has an issue that can be summarized as jack of all trades and master of none, which means that the system can work well for any kind of data, but probably is not the best for any of them. And of course, it introduces new distributed governance issues. So basically, the Discovery and Access Broker is a tool for applying the mediation pattern in the geospatial discovery domain. Without entering technical details, conceptually it's quite simple. It has a central component, which has an internal metadata model, which is based on ISO 19115. And it has some specific components called accessors to link with the data sources, supporting harvesting and distributed queries and mapping metadata model to the internal model. And on the other hand, we have other components called profilers, which maps back the internal metadata model to the target metadata model. It supports on the data source side several specifications, including standards and, let's say, community standards like UNAVCO, like threads, like GBIF. And on the user side, it mostly supports de jure and de facto standard specifications, so OGC, OIPMH, OpenSearch, and so on. It is part of the GEOS platform because we have heterogeneous data sources and the GeoDAB through its accessors connect them. Then it exposes application programming interfaces to build the GEOS portal, the community portals and apps. And here you can see the advantage is that you may have developers dedicated to each specific part of the architecture with their specific expertise. Some facts about the Discovery and Access Broker. As said, it supports a 10th of discovery protocols and profiles to connect the data sources and search engines, exposing standard service interfaces and application programming interfaces. It transparently maps metadata without changes, so it means that the content depends on what the providers provide, so including information on licensing, quality, and so on. It provides some advanced functionalities, for example, views, which means the possibility to expose only part of the entire content based on query constraints. So you may have views, for example, only of data core data, or only data on Europe, only data relevant for a community, and so on. In the GEOS platform, it connects more than 200 infrastructures and data sources. It is deployed on an advanced cloud infrastructure, which provides redundancy, fault tolerance, and elastic scalability. Its design, development, and operation is supported currently through the H2020 GEOS Platform Plus project. We have some content analysis carried out by the European Commission Joint Research Center in 2017 and 2021. It is actually also adopted in other systems, for example, the WMO Hydrology Observing System regional prototypes and some projects and initiatives. It's also a component of another product that we developed in CNR for model sharing and multi-cloud on multi-cloud environment. And its open source community edition is available on GitHub. So just to conclude, let's say the key message to summarize, the mediation pattern addresses the interoperability challenge with a dedicated logical component. It's a well-known pattern in software architectures. And the GeoDAB applies this pattern to geospatial data discovery, also access, but of course, today we speak about discoverability. It's an open source tool supporting 10th of discovery protocols and profiles, and actually it's conceived also as part of a more general geospatial data ecosystems that was also discussed in the GIDTT. And here in the slides, I put some reference. And it's all. I was maybe a bit longer, maybe something like 1 minute, sorry.
It's very, very good. Thank you so much, Paolo. A quick fix on the GeoDAB there. Congratulations. Any questions for Paolo on the GeoDAB? You don't have to be shy. Huh? Raise your hand or just take the microphone if the silence is too long. Everything is clear with the GeoDAB. Now, as you said, Paolo, it's a mediator, and that implicit is that we in GEOS is actually handling a lot of community portals and catalogs, and making them interoperable in terms of for discovery itself. I mean, there are many levels, many perspectives on interoperability, but discovering these different different community portals, repositories around and about from member countries. I mean, it's a great variety. Did you, I mean, Chris mentioned control vocabulary. How is that fitting into what you are doing?
Then that's a good, really good question. I mean, as I said, actually, the Discovery and Access Broker tried to be transparent. So actually, it publish and uses only metadata provided by the data providers. But of course, we also actually would benefit on the use of controlled vocabularies by the communities. We actually also made some experiment in using some semantic services to map the, let's say, keywords, the content, let's say, that providers are able to provide with the controlled vocabularies, and then use our discovery functionalities. It is feasible, but of course it's not the best solution because it introduces some delays and so on, and also it requires to have many different ontologies and their alignment, which is another very big challenge when you have multidisciplinary applications. So I think that this is correctly, let's say, faced in a certain sense, working with the communities and let's say in a joint effort, mostly from standardization bodies with the community, to let's say promote the use of controlled vocabularies in creating the metadata for the different data sets.
Yes, and we will hear, actually we will hear more about this later in this dialogue, just touching upon it. We have a question from Jacquemot. Maybe you can ask it.
Hi, it's Christine
yes?
Jacquemot. Yes.
Yeah, hi,
I just wanted to know how you work with the communities and how do you build the accessors? Is it a work of mapping, alignment between their standard and yours?
Correct. Yes,
Okay.
that's exactly the way. Let's say that historically, some years ago when we started working with the DAB, we needed a lot of effort in developing the accessors because, of course, every community has some different services, some different metadata model. I must say that today there was a sort of convergence. So actually, many communities already use, let's say, the factor, the Euro standards, for example, OGC, ISO, and so on.
Mm-hmm.
So for us, it's easier today because very often it's just a matter to have some interoperability tests and then use existing accessors. There is also the possibility for communities to develop their own accessors. We supported this in the past. There was some accessor developed by the NSIDC, the National Snow and Ice Data Center in US. Now we plan to release in the community edition the opportunity to actually provide also directly their own accessors. But this is a decision of the community. Let's say in Geo, the approach is that when a data provider registers itself in the yellow pages, then our, let's say, technical working group is put in contact with the provider, and we work together in these interoperability tests, and we see if there is a new accessor needed or just an adoption of something already existing.
Okay, so sorry, can I ask a second question?
Yes,
Have
go
you
on.
developed some interfaces for, I mean, a bit more user-friendly for this mapping, or is really through, I don't know, JSON schema? How do you work together?
Currently is done, it's, let's say, accessor are Java language components.
Okay.
And there is internally a description, but it's mostly used by developers. So,
Okay. Thanks a lot.
welcome.
Thank you, Benjamin or Benjamin.
Yeah, Benjamin, thank you. Thanks. My question is also related to a vision of the future related to what you have said, Paolo, because OGC already defined a linked data standard. Last week in the previous telco, we have someone from Google that also told that they are already indexing data sets because they already are using schema.org, some sort of data set schema and maybe other related JSON schemas that could be used or reused from the data that are provided by data providers. I don't know if there is a work or an initiative or a trend within data providers, and now I'm just thinking about the big ones going in this direction, so that maybe the effort that is being placed in the DAP will not be carried out by you, or will be reduced in a way that this data will be discoverable in a way through Google or Bing or other big large search engines.
Yeah. I mean, basically, our approach is, of course, to see which data sources are relevant for Geo, and this is a work done, of course, with the Geo Secretariat, and then, of course, adapt, let's say, the GeoDAB to access these data sources. So it is possible that through these sources we can access the data. And it's not, I mean, a technical problem, mostly in most cases.
No, well, that was partially a technical question, but at the same time a strategic question, because I think you are also in contact with these data providers, and probably you know better than me if they have also a tendency to move in the data direction, or still prefer to work with you or with someone that is building a global mediator or a global broker.
Yeah, I think that here, as you say, the question is not technical. I mean, is more in terms of governance and also the direction of Geo. Here probably the real point is how Geo pose itself in the general context of data sharing infrastructures. The value, what is basically the value of Geo? I think that the value of Geo is that the possibility to have an infrastructure or a platform, or as you like to call, which is open and which is a way to access many different heterogeneous data sources. I think that, of course, other actors in this arena may have other objectives and other, I would say, vision of how to evolve. But I think that what is important for us is to be in line with the objective of Geo. So,
okay, thank you.
Thank you very much. And I think that was a nice segue to the next speaker, to the next introduction, to the next presentation. Next, GEOS is an example of a federated system, coexisting with all the others, including GEOS, and we will see the link also between them. João Andrade will give us an introduction to Next Data Hub, Federated Data Catalog. João is a technical manager and senior software engineering of our subservation ground segment in Demos. He is deeply involved in the Next.js catalog, of course, and then also including big data, discovery, access, and processing and dissemination. He has worked in the space industry, so now we have somebody from from the private sector here. And I think, Joao, I will give the floor to you now, so you can start showing us. I think you will give us a demo, actually.
Yeah, I will share my screen. Okay, perfect. So first of all, before we go through the Next.js catalog, I want to show you some of the features and some of the interoperability that we have here in the Next.js catalog. But I want first to do a quick overview, so you can all be aware of the Next.js and the Next.js catalog. So the Next.js catalog was basically developed under the scope of an H2020 project called Next.js. Where the main goal was to present a new European vision, let's say, for data exploitation and to facilitate the data discovery. So it is basically a data catalog, and at the same time, it is also a service catalog, as I will show you during the demo. And it is important to highlight that in the Next.js catalog, we are only storing metadata. So this is not a data archive. All the data that we have cataloged here is still kept in the data provider's repositories. So we only store metadata. This Next.js catalog is based on open source software, essentially. In this specific case, it is based in CKAN, which is an open source, let's say, data management system used in many catalogs around the world, in fact. And most important, the Next.js catalog was developed based on OGC standards, what increases, in fact, a lot the interoperability with other catalogs. Too many aspects to highlight is the open search interface that I will also show to you. Also, we have developed data connectors for the Next.js catalog using many different OGC interfaces like CSWV, WFS, and so on. And another important aspect that we did with Next.js catalog is to somehow include a plugin that allows us to expose the metadata that we have stored as a DCAT standard. Okay, this will allow us to directly make these data sets discoverable through Google dataset search. So I can quickly show you. If you go to the Google dataset search and you type, for example, Next.js, you will find lots of data sets that we have in the Next.js catalog. You will find them here, so you can access to the data set through the Google. Then you will be directed to the node where the data set is, since this is a distributed catalog, and then you can get back to our Next.js data portal. So this is basically to say that including this plugin, this DCAT plugin, and exposing the metadata as the DCAT standard, we can also make the data sets findable through the Google dataset search. Going back to the Next.js catalog, it was built as a distributed architecture, which allows us to distribute the metadata by different nodes. This increases a lot the flexibility of the catalog, the performance, and in fact, the way it is built, it will allow us to add new technologies as metadata nodes. So right now we are using CKAN, but we can in the future evolve it to use other metadata catalogs like Elasticsearch or other databases. I don't know, but it is quite flexible to be evolved and to include many metadata nodes to distribute the metadata and increase the flexibility and performance. So the Next.js catalog itself, you can explore it after the seminar, of course, but I will quickly go through it. It contains a regular search panel with many features like keyword search. You will have some suggestions when you write the keywords. Here you can search by a specific location. So if you write, for example, Lisbon, all the searches you did will be over Lisbon. Then you can draw your area of interest if you want, perform time interval queries. Another important stuff is that in Next.js, we classify the data by satellite data, in situ, model, and statistics. So this type of catalog is typically tailored for satellite data, but in this case, Next.js is also available for in situ and other types of data. In fact, we have a lot of in situ collections if you explore a bit later. And then you can search by all the data collections that we have that we have cataloged here, and we are continuously cataloging some of them. The data organization, we organize the data by data provider and data collections mainly. So in XGeos, we have cataloged data from 42 data providers until now, and we have more than 180 data collections associated to these providers. And both the data providers and data collections are also classified as satellite, in situ, model, and statistics. Then when you perform a search, just to quickly show you, for example, for a specific data collection, you will have the data sets here. Okay, you will have them displayed over the map, and then you can access those data sets and see more metadata. And you have the URLs to access the data directly on the data provider repositories. So this is the basic functionality of Next.js, but about interoperability, it would be great to highlight the open search interface. So all the queries that you perform in the front end, you can also use this button to perform the same query using the open search interface. This is really important because first of all, it's a standard interface that will allow us to federate with many other catalogs, and at the same time, it can be used as a machine-to-machine interface for programmers or application providers that want to find data here in Next.js. Some persons are quite used or familiar to use this kind of interfaces, but for those that are not, we have included this button that will allow you to do this exactly same query that you do here in the front end using the open search. And in fact, it was this open search interface that allowed us to connect with the Geos. So today, if you go to the Geos portal, I just will refresh, you will find the Next.js here as a provider. Okay, so you will find Next.js here, and if you select it, you will be able to find through Geos the data collections that are cataloged in the Next.js catalog. Okay, so you will find them here. And we also did the other way around. So we have integrated the search in Geos widget here. So you can, from Next.js, search directly in the Geos portal. So this kind of, for this kind of interoperability, is quite important to use these standard interfaces. I just wanted to finish. I don't think I have much more time, but I would like to discuss also about this new feature that we are testing in the Next.js catalog, which is instead of cataloging ourselves the data, just to perform a federation of data catalogs. So right now we were testing this new feature using the CreoDish catalogs. In fact, we'll probably remove them because CreoDish just reported in the last days some issues with course policy. But basically, the idea here is that everyone that has or knows about the data catalog, providing and publishing the metadata using an open search interface, we are able to federate that catalog with a small configuration, and the catalog will be available here. So imagine that some of you as data providers has a catalog with an open search interface. You just have to contact us. We can quickly configure that open search interface here, and you will see your catalog here. And when you select it, you will be able to search over your catalog and find the data in your catalog through the Next.js. So this feature is quite, we are quite happy with this feature because it will allow through a standard interface to federate lots of data catalogs across Europe and across the world. And of course, make the data much more discoverable. I think that's all on my side. Not sure if you have questions or Bent, if you want me to highlight any other topic.
I think this is a great illustration of a federated system, linking also to Geos, representing also a federated system, but in a different solution. And I think this is the complexity that of catalogs, and data, and where we have the data. The in situ data has a special challenge by being less discoverable, if one could say. You have small local repositories that could be very hard to discover. and you have, as on the other side, you have the space, you know, the satellite data from, as you've shown, the Copernicus satellite data, immense, bigger data that is more easy to discover. And as a user, discovering exactly the right type of data for your use, and your use can be not only the thematic use and the problem you are solving, but also the technology at your hand. Some need to download the data to use them. Some need to do the processing of the data in a cloud. And what we see here, you need to discover not only the data themselves, but also how you can access them. And I think that's part of the metadata in Next.js. The complexity is clear, and you see technology is allowing us to find solution to this. And by that, please do ask questions in the chat or raise your hand. While you are thinking of a question for Joao, I will end the poll and share the results with you. For data providers, we will ask the same type of question for data users later in this dialogue. But for now, thank you for participating. For data providers, are your data discoverable on the web? You showed many different ways of discover data just now. And we see that, yes, mostly they find that they can discover data via community portals. That's 45%. And 25% say yes, they are discoverable in GIS. 20% says yes via search engines in general. 20% no, they are not discoverable. And then this other, a big chunk actually, is another other solution. Can I challenge the attendees here that answered other? Can you comment on that? Any of you? Raise your hand. Is it because you don't have data to you're not a data provider maybe?
For the ADC, I answered that because we're not a data provider.
Yes, right, exactly. So this maybe it's the non-data providers, because they're not everybody's a data provider here. But it's interesting that yes, via community portals. And this, being a member of the GEO community for many, many years, I know that some of the members of the community that are in a very tight-knit community, they know where they find the data. They go directly to the community portal, and they don't necessarily see the usefulness for GEOS or Next.js or Google search or whatever. However, that is not contradictory to, these community portals are not contradictory to GEOS or any other search discoverability facility, because there you have new users, you have users from outside some other type of community. And that is, by the way, one of the reasons we have GEO, to provide this link, this community where we can have discussions across the different communities. But this is a general challenge. And yes, I will stop there. I was hoping that more people would be, I mean, this is a dialogue, so warm up to the next, after the next presentation. Or maybe, Paolo, did you want to say something too?
Yes.
Yes.
I see there are some questions in the chat. So
okay,
in particular, one from Piotr asking, how do you envision ad hoc online federated query ranked results merging? This is a question about ranking. I didn't mention these. Actually, the Discovery and Access Broker provides a way of ranking results. Of course, there is an issue that is, we can quite easily, let's say, rank those queries that are coming from harvested metadata is a bit more complex with those coming from distributed queries due to delays, possible delays in the answer. And of course, the real problem is not making a ranking of results, but to decide the algorithm from ranking, because of course, ranking depends on users. So we actually provided initial proposal of ranking. Then we had some discussions in Geo about how actually give the different ways about ranking. But this is actually an open discussion, and that's something that should be probably restarted in some way. But the basic answer is that we support ranking, but the decision about the algorithm to use for ranking should involve, let's say, the community in general.
Thank you, Paolo, and thank you also for, I didn't see the questions. I see questions, but no hands, you know. And this is maybe an interesting question. What is the difference between GEOS portal and NextGeos?
Yeah, I was looking to the questions, Bente. I was saying that probably for that one, maybe you or Marie-Françoise would be better than me able to respond, in fact, because I'm more familiar with NextGeos. If you could respond to that one, and I will go through the others.
Marie-Françoise, the floor is yours.
Yes, I can try to help, because the idea of the session today is also to demonstrate that, as a matter of fact, there are many catalogs, because a catalog has a governance. It can have be specialized on a certain type of data, for instance, satellite or in situ or citizen science or whichever. It can be specialized over a region, focusing over a region. It can specialize on a thematic domain like Sergio is going to present later. So as a matter of fact, we have different catalogs. And the idea is to see how we can federate them to give the benefits of all of them to the users. Between GEOS and NextGeos, they have a different governance. GEOS, as Paolo said, is cataloging the data of interest for GeoSec. NextGeos, the start of the data hub was driven by the needs of a set of pilots, and then it has expanded. And the goal of NextGeos was also to connect cloud capacities to be able to process the data near the data. So it was also providing some cloud capacities. So in fact, the governance and the topic on how they have been built are different. My understanding.
Yes, and at least now, NextGeos is also cataloging services and applications. I think this is on the plan also for GEOS, but currently this is what NextGeos were developing a catalog, easily cataloging the resulting, not only resulting, but the resulting products and services created, and where NextGeos platform services were used, not only the catalog, but the other services. And other types of data, statistical data, economic data, etc. So a little bit wider in thematic areas, but not as widely, I mean, in terms of numbers of data sets.
I'm seeing some questions here. So
yeah,
how do we manage the duplication? So if I understand well, you were talking about the data sets duplication on the data collections. So on our side, for the data that we catalog, as we organize the data by data providers and data collections, we typically don't have this kind of problem, but imagine that we have a data provider providing exactly the same data collection. So in that case, we will use, of course, the collection IDs to merge these data sets. And also we will go through the identifier of each data set. And if the data set is already on the catalog, we will probably add metadata and add other resources to allow the download from both providers. So we will not let's say, overwrite the data set. This is how we handle internally in the next use when we catalog the data. For the federated catalogs, in fact, as I showed, we will have many options that you can select for all the federated catalogs. And when you search, when you select one of the federated catalogs, you will only search over it. So you won't have data sets duplication on that kind of approach. So in fact, this problem is quite typically quite simple to solve, mainly with the organization of data collections and data providers. Then I'm seeing another one regarding data cubes related to forest dynamics. So in fact, the Next.Use does not have at least the Next.Use catalog does not have the concept of data cube, but I believe that some of providers has this on their side, but on our side, we just catalog the data with the concept of data set. So in fact, we don't provide data cubes, but I believe that some of the providers that we have cataloged provide this kind of service. Also, in fact, we have beyond data catalog, the service catalog, which we organize services by thematic areas like agriculture, forest, marine, and so on. So probably some of these services that we have cataloged provide these data cubes, but the concept, let's say, is not available in Next.Use. We catalog data with the concept of data provider, data collection, data set. So not the concept of data cube itself, but maybe some of the providers that we have cataloged has this concept. So
Yes.
I'm not sure if I responded to all the questions. Let's see.
Looks like it for
Yeah,
now.
I think so.
Yeah, and I think so. In interest of time, to make sure that we have 2 more speakers, so we will dive into this more into richness of metadata with Rob, and also to the future technology solutions, I would say, for discovery. And then, as Marie-Françoise reminded us, we will see an example from a thematic area, and that's from the global observing system for Mercury by Sergio. So I think we are ready now to introduce Rob. But before you start, Rob, I would like to say a few words about you. So Rob, he works at OGC, and he's responsible for establishing and implementing best practices for OGC publications of semantic resources. We are going to talk about semantics. Brace yourself. And he managed the OGC definition server on behalf of the OGC naming authority. Rob has been working in academia, in heavy industry, NGOs, etc. Very wide background, and reside with us. He is with us from Australia, I believe. So thank you very much for joining us. An expert on standards supporting OGC. The floor is yours, Rob.
Hi. Yeah. Thanks. Can you hear me? All right.
Yes.
Yes, okay. Yeah, so a lot of the topics have been covered a little bit, but I'll provide a few fresh perspectives on this from a theoretical perspective of what we might need to do moving forward. And particularly it's through joining together the various different types of metadata that we may need to meet our goals. So if I success. So very, very quickly, a perspective on the geo sharing principles is from the perspective of interoperability, the open data principles in particular, they reduce complexity because they take away all sorts of complexity around working out how much the data is going to cost, depending on how frequently you get it, what resolution you get it, what different versions or different options you might have, how accessible it is, how reusable that data is. Do you buy it once or get a license, blah, blah, blah. I mean, it's already a complex enough problem with all that. So you can do things to reduce the complexity from the user perspective. So yes, the geo data sharing principles are a great start. Let's look at some of the other causes of complexity. So as has been mentioned, which is great, there's many catalogs, there's many different metadata schemes, and there's many rules for the content within that. Different communities specialize, as Bente was just saying in the comments, for different purposes. And each of those metadata schemas have different facets, and they may be common or domain specific. But generally, only the portals know what's in the data catalog. So when you start federating it, it's very difficult to have a very coherent view, which is rich. There's a lot of things like reliance on naming conventions for resources. Okay, and yeah, it becomes very challenging when you start aggregating it to get the same richness of behavior or meet the expectations you can at a local level, at a wider level. So another way of looking at this, and I've just pulled together just a quick example somebody published about some stuff, in this case, calculating algal blooms, basically bringing in some data from a satellite, we know which is going to be of its at some time using some sensor at some resolution, connecting it with information about the spatial objects of interest or some previous samples or something. The information about that might be calculated via some model in order to get some view of some measure of what's happening. And then the in situ data, there's a whole range of possible in situ data that you may use. Some sample data comes in. So some sort of a workflow generates some useful data. So that's an example. Okay, but so that's something happening in our estuaries. If I wanted to do that in inland waters in Australia, could I reuse the same model? Could I, if I wanted to do something similar, could I reuse the same data? Knowing how the data has been used is one of the most important ways of understanding the data itself. So if you think about this from the perspective of discovery, we have our typical sort of what we've just been describing. The data is exposed by a service which expresses some sort of metadata that should be put in a catalog record, which may reference back to the detailed information of what the data is, some document describing the data. When we start putting it through a process, we start bringing other data. There's a model, and we generate new data and the metadata for that new data. Okay, and that's great. If I then want to ask that question, what data can I put into that model to produce that? I mean, if I want to do it for a different region, or I want to update it for this year or something like that, what do I need to do to find the data, the other data that I can feed into that? What if I want to put some other variables? I've got information about phosphate runoff. Let's say I want to understand what the fertilizer load or agricultural yield in the estuaries were. I want to put other information into that process. So, well, I need to maybe find more information about the model, what type of data it actually, what's the specification that the model requires to run. But in order to start answering queries, I actually understand the provenance. When that model was run, what metadata did it use? What data did it use? What model, blah, blah. So we can start saying, well, there's a piece of provenance metadata which I might need. Not typically handled in our catalogs, but there's no particular reason it couldn't be. And then you might want to describe the data, what, when, where, how, the sort of statistical dimensions of that. And then you could actually start asking questions about what other data could I use? Could I, if I want to go into more resolution, finer resolution, or coarser resolution over a larger area, or look at more time, look at a wider area, all these different questions may require a deeper description of the data, which may require some analysis process and capture of that. So you start to see we're actually building this network of pieces of metadata, which are not necessarily our traditional metadata records. So we're creating some sort of a knowledge graph. And then at this point, you can start thinking, oh, well, there's actually this concept of linked data, which has been mentioned a couple of times, and the concept of maturity. And the idea is we move towards machine readability of it, which basically means we have more pieces that need standardizing. So that's the implication. So the roadmap for the OGC in this space is that, we've had this OGC reference model, a lot of OGC standards, quite closely tied to things like geo and geos requirements. But we're now finding a lot of other different architectures as we start moving up the value chain, and we have different cloud native systems. We have sensor webs and edge computing and all the other things. We have been capturing the specifications and the definitions that we're defining through the naming authority process. You have a definition server, which is being evolved to produce a modular, standardized, machine readable approaches to publishing the standards for those types of metadata, not the data itself. But in the future, we're looking at actually building our own resources into a more dynamic knowledge graph and abstracting out reference architecture really around the FAIR principles across multiple different architectural patterns. So as we saw one architectural pattern described in good detail, it's all good. There are actually many architectural patterns. The metadata may be common across different architectural patterns, and we need to think about what that means. So there's a little roadmap about what we need to think about. The definition server was mentioned is kind of just the evolving toolkit, and it's sort of really about a fair enablement to support system design. How do we publish the resources in a fair way that you might need? Resources such as conceptual models, which provide a high level of abstraction to say, okay, right, here's 3 different ways of encoding different aspects of this conceptual model. We might have a conceptual model, for example, observations and measurements. Here's SOSA, the ontology version of it. Here's the GML schema for that. Here's a JSON schema for a particular type of Earth observation. I mean, all these things exist. Tie them all together. That's kind of where conceptual models come in. But then we have the other flip side, which is profiles, which a number of people have mentioned, which is where we start defining in more detail how a particular domain uses one of those standards. Linked data, which is the ability to then link these pieces together, discover things by the relationships from what you already know about. You start somewhere, you can see everything else. And then that leads to extensibility of metadata models, which I guess is the key message I want to talk about here. So we're looking at bringing GeoGCAT under formal governance, and then looking at extending it further, have GeoGCAT for provenance extensions, GeoGCAT for statistical data extensions. And these become sort of modular extensible schemas which can be used. And that's probably all I have time for, just a quick taste of where the future may be going. So thank you, and I'll take any questions.
Thank you very much, Rob. I know that wasn't easy to do in such a short time. In summary, I will say that, what struck me anyway was that we in Geo, we have been talking about data discovery. Then we have been talking about analytic ready data discovery. And now I also know that you're talking about decision ready data. So there, we are looking at data in a, I guess you said it, higher in the value chain. I mean, in the value chain of going from raw data to a service or science or whatever application. And you pointed us to some of the very demanding challenges that then needs to be addressed and solved. So now, do we have any questions, raising hands to this? Can you unshare your screen, perhaps?
Yep, stop
Yep.
share. Okay,
Yep.
that'll allow me to find buttons like.
Yes. Thank you.
There I am. Okay.
So, but as a comment to these presentations, when before we go into an example from a community, you see here that from a data user perspective, can you find your data need? Overall, yes, but searching for data is very time consuming. So I guess all the efforts we make to make data easier to discover will be highly appreciated by the community. 28% know already where the data is, so that's why they can find them. And that was basically nobody find it easy to find the data that they need. So with that, Sergio, well, Chris has a comment first. Yes, Chris.
Just a short question to Rob. Do you think such documentation we made and we established since 2010 with this data management principle as readable document is really fit for purpose and for the future, or so just as a text? Or do you have other opinions? So regarding the FAIR community is really developing tools to measure the metrics and to measure the to assess the quality.
Yeah, that's so when you come to principles, I guess they're quite abstract. When we do standards for the last probably 12, 15 years, we've had a concept of a modular specification policy where we explicitly identify what we call the conformance target. What is the thing that is supposed to follow? So when you have these abstract guidelines, then the conformance target or the thing that you're trying to influence is probably the next sort of tier down, the things which can actually be validated and supported. So I don't see necessarily a problem with them in their current form. It's like the FAIR principles, and so most of these principles are very useful to have them articulated neatly. But you then have to apply them and then come up with the metrics to say, right, so yes. I would look at metrics, for example, how many steps, how many hops do I have to do to find my answer? And currently, if I want to use data, you find in the catalog, and then you often have to do things like say, oh, that data may or may not be interesting. If I don't already know, I will find someone who knows that data, who's already used it. Can I use that data safely? Where's the scientific publication? Users are doing a lot of hops, connecting the dots outside our systems before they can actually answer a question at the moment. So they might do a very, very quick, efficient catalog search, but then might have to spend another year doing literature searches to find out how to use that data. Whereas if they could actually see quite, here's the series of operational chains that data is already used in, you might say, okay, right, well, I can much more quickly see how relevant that data is, or whether I can use the same processes, or whether I should capture the same sort of data in my own area because those processes are good. So I think the value generation from the data through processes needs to be treated as a first-class concern. It's as valuable as the data source itself often as a reusable thing. It's often the thing which gives the data value because it's known how to be used, and it's part of the reusability, which is, again, the high-level principles are quite good, but yeah, it's what other steps can we help by making it less onerous to chase the literature.
I think it sounds like a topic that would be interesting to dive into, maybe in a continuation in the dialogue series. And it's linking different data management principles as well. So I think that would be interesting. But now, Sergio, we are going to hear about an example of discovery, of following discovery. So Sergio Cinirella, he is a senior researcher at CNR in Italy, and has a very long experience, 30 years in different national and international projects, has been leading several of them. And I highlight here that you have been also deeply involved in various EU projects on the global mercury monitoring network, DMOS, IGOSP, and also related data infrastructures. And you are a showcase leader in the health surveillance in A-Shape, this European project, and Italian delegate to Minamata Convention on Mercury since COP3. And you are also evaluating the GEOS work plan implementation. And of course, one of the members of the Geodata Working Group. So, and here you are going to talk about your the Global Earth Observing System for Mercury flagship, one of our flagships, where you are also one of the contributors. So Sergio, thank you for your patience, and we are excited to hear about Mercury.
Thank you, Bente. Do you see my screen, I guess?
Yes.
So, first of all, I want to acknowledge the main projects that helped the Goose Forum to go from an idea to the current TRL. The main was IGOSP that provided the development of the knowledge hub of Goose Forum, but eShape, I guess, is powerful in this way. So, two slides to give you an idea on what is the flagship, because some of you know very well, other less. The flagship was established to support the United Nations Global Partnership on Mercury, with the aim to provide global data sets, comparable and harmonized within existing regional and global scale network. Actually, it provides a knowledge hub that integrates Earth observation data sets and modeling tools to drive policy in the development their scenarios. And of course, it was developed to evaluate the effectiveness of measures undertaken under the Minamata Convention of Mercury. Few key aspects of the Knowledge Hub. It is an integrated multimodal and multi-domain computational platform because it includes different models, ranging from models useful to understand Mercury cycle in the atmosphere, but also in the marine compartment and in the biota. At the end, as you understand, models are not useful to policymaker. We developed a chemical transport model emulator that can provide a scientific-based information on Mercury endpoints. We share, the Goose Forum shares in situ data, model outputs, application programming interfaces, which enable analysis of scenarios for policymakers. So, which are the resources on which is based the Knowledge Hub? We have a number of monitoring stations around the world. Some of them are directly managed by CNR through the Global Mercury Observation System, GMOS. They are both active and passive monitoring sensor. We have in the infrastructure oceanic monitoring campaign data and atmospheric campaign monitoring campaign, but also output of models, because all these data are not useful to policymaker unless you provide them something that can be understood in a simple way. Currently, we have 112 data sets. Some of them are in situ, active and passive monitoring station, 18 oceanic campaign, 31 atmospheric campaign, 3 models layers, each one holding 130 runs, and API provided as services. Of course, each resource has its own metadata. I will talk a little bit about this because at the beginning we managed a very high number of metadata, but we found this approach unuseful. The current discoverability is made available through a catalog. Of course, the metadata provides the URL to datasets, but also several formats of download are made available. Which are the components that are brought to the public? The first one is the data catalog, which holds all metadata. You can find here the endpoint of this, but also we have not we directly, of course, the Geo Secretariat has brought really a big effort on this. We have a community portal, and also we provide information for the Geo Knowledge Hub. How everything is linked, is connected to the Geos portal and to the community portal. The engine is the GeoDAB. The GeoDAB harvests all metadata every time we do a change. We send an email to the task of that is developing the GeoDAB, and they do the harvest of the metadata. Key message that I want to share with you. We started with a very high granularity of metadata, more than 1,000, but their management was very difficult. At the end, we synthesize everything to 112 key metadata. Of course, metadata is a very tedious activity. The last mile is very heavy, and this is an activity that most of researchers don't want to do. But we have established as Gus4M a governance. So all decision on data sharing, on licenses, on everything that concern the data sharing is much more simple than having different and scattered providers. And one more thing that I want to give you as point is that we do not provide data and services for science, for researcher, but they are mostly policy oriented, because as I said, data themselves are not useful for policymakers. They want to understand how trends can be interpreted in the next coming year. So they want to understand scenarios. So in these few minutes, this is my real short experience.
Thank you so much, Sergio. Indeed, not easy to make short either. But I think we will learn more about, well, first of all, the main knowledge hub that you mentioned was your Gus4M knowledge hub that you created, right? For expert users, yes. And then, but we will have a Geo knowledge hub that will be covering more topics and thematic areas, just to clarify that.
Yeah.
And this we will learn more about in a later dialogue also, by the way. But it's good to see, and I think it's a very nice illustration that both has value, both a very tight-knit community and a wider community. We need both. Okay. Do we have, well, we are 3 minutes over our scheduled time, but I know I jumped over Marie-Christine. So I will, well, first of all, are there any questions here for Sergio? It was a very nice example of how to use data management principles, and Discovery in particular highlighted, and see how that, I think showing several of these examples, and this is what we want to do in the dialogue series, showing these examples will help us then find solutions for our own communities. While you are thinking of writing or raising your hand, I will just jump to Marie-Christine, who had a question to, I believe that might have been Rob, or have you developed? Yes, go ahead.
It was for Rob. Well, I was just curious, but maybe I'm too far ahead, whether you had developed or you have some tools in mind that could really enable scientists to really capture all that really rich metadata.
Yes, that's an interesting, what we're looking at doing is, I've been working with a number of projects, like in the agriculture space, Demeter and Sibeli, and others, and now the Iliad project, Digital Ocean Twin. And we're looking at developing profiles of OGC standards, and things like GeoDCAT, and observations and measurements, and developing validation suites for those, so that people can validate and also build profiles. With building profiles, the connecting of the standard to the control vocabularies you wish to use is an area where there's actually a bit of a dearth of standards. And it's a bit of a challenge for us because it's not purely OGC geospatial problem. So that's an area we're currently looking at. But yeah, look, that's kind of what we're morphing the definition server into, is actually providing worked examples of how to use these things, regression testing suites, but mainly to help developers, not really for runtime systems, but to help with the development of those standards. So sorry, it's a slightly long-winded answer. I can take it offline.
Oh, it's okay. It's interesting. Are you aware of the CEDAR software tool that was developed by the bio community in Stanford?
Yes, I have come across that. And there's a few communities who've done pieces of this. What we're looking at doing would be generally supporting communities building their metadata standards on the modular pieces that they decide they need.
Yes. Yeah.
So I don't think we'll never get perfect metadata in full detail of everything. Different communities will have different pieces. But what we hope to do is actually start a sort of a network of pieces which evidence of how they can work together, and build a library of those up as best practice.
Yes, indeed. And I take that as a segue actually for a motivation to make your data discoverable through many different catalogs and systems, if possible. And I think in eShape you have done some research on that, Marie-Françoise, if I'm not mistaken.
In eShape, we are pushing the pilots to go to business. So from research to business, we address this specific difficult step. And I have invited Miriam Cosmal to talk, but she could not be available. I hope she will not mind if I share a bit of her presentation. If I can share screen. So the idea here and why I wanted to invite Miriam was to present that they have developed a pilot, which is now operational, and they have published the results. So this pilot is about harvester seasons and trafficability for harvesting in the forests. And so they explain here what is the goal of the pilot, but what I would like to highlight is that the results of this pilot are published in several portals. So there is a dedicated community portal, there are APIs, and there is the Finnish geodata portal, the GEOS portal, and so on. And so there are many references to these results. And what is interesting here is that you can have some analytics tools. So Google Analytics is one that is free for the basic capacities. So this is the ones they use here, but you have others. And with these tools, you can see where the users come from, because the problem with the web, when you publish on the web, is that in fact, you don't have your user in front. So, well, you have your basic user. The first user is in front, and this is the one that helps you co-design your application and your results. But when you publish, you don't know who are you reusing and where they are. So these tools allow you to see where they are, and what you can see that the different portals address different communities, and then you can reach audience that you would not expect. Here it's a Finnish portal, and they have users, a lot of users in the US and in China, for instance. You can see the language of the users, and this can be interesting to see if you have to translate. Finnish is not accessible to all of us, so it can be interesting to see that it is worse to translate in English. This was also mentioned a bit by Paolo. And what is interesting here is to see where the users come from, because you have published in several portals. The system is distributed, and then you want to see where the users come from, and you have this information of where they come from, and you can analyze. Okay, they come from directly from my community portal, they come from my national portal, they come from articles on the web, they come from conferences. And this is why this is related to discovery, because you publish on the web, on one or on several portals, and you have to know that you have tools that will allow you to see what is the publication which is the most interesting. And the standards allow to republish your results in several portals. And we have seen NextGeos that connects from NextGeos to Google. And this is why it's important to have a system of systems. And you have tools to analyze and optimize your publication and to learn about your users.
Yes, and for me, I see that it's worthwhile, is an illustration that it's worthwhile to publish your data several places, because you reach different user groups. I have a question then to Sergio. Did you publish your data other places than in your community portal and GEOS? Did you consider publishing it elsewhere as well?
Yeah, we published our data in NextGeos.
Yeah.
We registered all the system in NextGeos. And this is all, not other registration we have done.
Right, but this is, I think this might be the future for the focus of GEO now, to have more, impact with the Earth observations, is to actually need to follow closer where, how we can improve the discoverability. And I have to apologize for, I thought I was sharing the results of the poll with you guys, but I realized that I did not. Now I share the result of, if you, as a data user, if you can find the data you need. So you see that it's a lot to win in improving these discoverability of your data. People are using a lot of time to search. Any other questions? Did I, let me see if there are more questions. Raise your hand if you have. We are long over, we are 12 minutes over 1.5 hours, so I think we are pretty done with the whole thing now. May I challenge you to turn on your cameras and we take a group picture again? The last thing we do before we take a well-deserved break. So I will enhance. Yes, thank you so much for this. Joa, Valeria, Alexander, Piotr, Ramirez, George. Maybe people are taking some breaks. Smile. Thank you very much. You deserve a break.
Okay.
Next week will be accessibility.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Thank you.
Thank you.
Bye.
Bye.
Thank you so much.
Bye.
All right.